This podcast is going to be about the physical property of density. We've been talking about all these different physical and chemical properties. Well, we're going to spend several days covering one particular physical property, and that's the property of density. Now, these notes, you can write them in Cornell style, and they're going to go on page 35 in your interactive notebook. So I'm going to start off by defining what density is. Density is mass per unit volume, or the way I like to talk about it is how heavy something is for its size. So when you consider something for its size, for how big it is, does it feel really heavy or does it feel not so heavy? For instance, a bowling ball for its size is very heavy, so we would say it's very dense. But imagine another object of the same size but made of styrofoam, for instance. A big styrofoam ball would weigh a lot less, and we would say it would be much less dense. So it has to do with not just how heavy it is, but how heavy it is for how large it is. So here's an example. For instance, we have, imagine 2 blocks, and they're filled with these particles. Doesn't matter what the particles are, but they're filled with these two blocks filled with particles. This block has only 1, 2, 3, 4, 5 particles, and this block has lots more. So we would say that this one is more dense because it has more particles for the same amount of space. And here's another example. In this case, we have 2 blocks, and they both have the same number of particles, 1, 2, 3. And because this one has a larger volume, you can see the particles are more spread out. So we would say that this one is more dense because the particles are crammed together. So the more crammed together the particles are, the more dense it is, and the heavier it is for its size. Now, as we talk about density, there is some math involved because density is not something you can measure directly. It's called a derived unit. Derived unit. And that simply means you have to calculate it. It's not something you can measure like mass or volume. But you do have to know mass and volume to calculate density. And specifically, density is mass divided by volume. Because of that, the units for density are grams, which go with mass, and cubic centimeters or milliliters, which go with volume. And that's why these are the units for density. But remember, you have to calculate it. It's a derived unit. It's not a directly measured unit. Now, before we continue on, I want to make sure we're clear about what mass and volume are. Remember, mass is the amount of matter in an object. The amount of matter. You can think of this as the number of teeny tiny particles. If you could count them, which is ridiculous, so we don't count them, but we actually measure mass as weight. Mass and weight are not the same thing, but we pretend like they are, at least for the time being. And so mass is the amount of matter in an object, the number of particles, or we measure it as weight. And then volume is the amount of space something takes up. How big it is. Is it big? Is it small? Versus what does it weigh? Those are two very different things. Make sure you get them straight. Okay, now that you kind of know what density is, let's talk about the density of some common substances. Air, for instance, is really small. Small density. Lead is bigger. Gold is even bigger. Gold is really high, 19.3. Aluminum's not very much. So these are the numbers that you get when you divide mass divided by volume, mass over volume. And our standard for density is liquid water. So if we have pure water, H2O, pure liquid water at room temperature, not too cold, not too hot, it has a density of exactly 1. So it's 1 gram divided by 1 cubic centimeter. That's going to give you water. Ice is less, and that's why ice floats. Wood is less. That's why wood floats. Okay? Aluminum, steel, silver, lead, mercury, and gold all sink. So that might give you a little bit of a hint about density. Okay, so to determine about floating and sinking, there's a rule. Any object that has a greater density than the fluid it's in will sink. But if its density is less than the fluid it's in, it will float. Okay, so we usually talk about water. Water has a density of 1 gram per cubic centimeter. And anything with a density greater than 1 will sink in water. Anything with a density less than 1 will float in water. But that could be the case for, any fluid. You could determine that. We usually talk about water, but you could talk about any fluid. You could talk about lava, or you could talk about oil, or you could talk about vinegar, or any kind of fluid you could think of. So think about that. Coins are going to have a density greater than 1, and a cork is going to have a density that's less than 1. Corks float and coins sink, I hope. Now, one of the things you need to know is that on the FCAT, they're not necessarily going to ask you just for density. They're not going to necessarily just give you mass and volume and ask you to calculate density. Oh, by the way, they will give you the equation. They will always give you D equals M over V. They will give you that equation, but they may ask for density, which would be an easy question, or they may ask for volume, or they may ask for mass. And you have to be able to manipulate the equation. That's algebra, folks. They're going to ask you to do some algebra with this, but there's a trick to it, and I think Miss Medalonis talked to you a little bit about these triangles, but I want you to write this down in your notes on page 35. Draw this triangle. This is our density triangle, and this will help you. If you memorize this, it will help you for the FCAT to be able to answer any question having to do with density. So it's D equals M over V. And the way you work it is, if they are asking, for instance, about density, it's mass divided by volume. But if they're asking for volume, it's mass over density. Okay, and you can see that here. Or if they're asking for mass, you simply do density times volume. Okay, so hopefully you can see how this triangle can be helpful for you to be able to figure out how are you going to do the math if they ask you for volume or mass based on density of something. So copy that down, and then I'm going to ask you to memorize that when it gets close to FCAT. Okay, now this is important. I want you to practice with the math, and we're going to do more practice in class when you come to class. But for now, I want you to just, after I go over the problem, I want you to stop and try and figure it out on your own. Pause the video and stop and try and figure it out on your own before you check what the answer is. Alicia has a sandwich, and it has a mass of 4 grams and a volume of 2 cubic centimeters. And what's the density? Remember, density is equal to mass over volume. So our mass is 4 grams, and our volume is 2 cubic centimeters. And hopefully you know just 4 divided by 2 is 2. It's a simple one. 2 grams per cubic centimeter. Make sure you get the units correct. If you don't get the units correct, it's not correct. It's very important. Okay, so there's the first problem. Hopefully you got that one right. Second problem, Alicia wants to share her sandwich with her friend, Mia. She cuts her sandwich in half perfectly. What is the density of Mia's half of the sandwich? Well, this is kind of a trick question because density is a property of matter. It's not like mass where you cut it in half and it's half, or volume where you cut it in half and it's half. Density is a property of that piece of matter. So if you have a given sandwich, its density is the same no matter how you cut it. So her sandwich would have the exact same density. No matter how big a piece you had, it would be 2 grams per cubic centimeter. And if you want to be sure of it, you can do the math on it. You don't have to, but if you don't believe me, think about this. If you cut the mass in half, it's 2 grams. If you cut the volume in half, it's 1 cubic centimeter. And the answer to 2 divided by 1 is, of course, 2 grams per cubic centimeter. So if you don't believe me, do the math on it. But I'm going to tell you right now, for any object, density is a property of that object, and it will always stay the same even if you have a tiny piece of it. Okay. Before the end of the podcast, I just want you to consider one more question, and then that'll be it for this one. Jake has a book. He has a ruler and a balance. How can he find the density of the book with the tools he has? Think about that for a minute. All right. Now, to understand density, or to figure out density, you need mass divided by volume. So, in order to find mass, we need a balance. Okay, so he's going to use the balance to determine the mass. And then he has to figure out the volume. Well, volume we measure with a graduated cylinder or a beaker or something like that. But we could also measure volume as length times width times height. And we can do that with a ruler. So use the ruler to measure the length, width, and height of the book. Multiply those. That gives you our volume. And then we weigh the book on the balance. And lo and behold, we divide mass divided by volume, and we get the density of the book. I hope you got that one right too. Okay, that's all I have for you for this lesson. And I hope you wrote down those notes on page 35 in your notebook. And make sure you bring those to class, and you'll be getting some credit for those notes. And we'll be spending probably about 5 days learning about density after this. See you tomorrow.
Made with vodcast Pro.